Welcome to Dividing Complex Numbers. So this is the 3C notes. I just put up a reminder here. This is the main reason why we have dividing complex numbers. We have this learning target is your final answer cannot have an I in the denominator. And I'll kind of fill you in why after we do example 1. So to look at example 1, you need to look at first look at the denominator. So is the denominator a monomial, so one term, or binomial, two terms? Well, in this case, this is a monomial. The denominator is a monomial. With monomials, with imaginaries, you're going to multiply by, all you have to multiply by is I. And when you do that, we're looking at the numerator. Look at 3 times I, that's 3I. Look at our denominator, 5I times I. I times I is I squared, so that's 5I squared. After you multiply, so second step, multiply. Third, simplify. So you're looking for, are there any like terms? Are there any I squareds? And in this case, there actually is an I squared. So let's look at this. We have I squared here in the denominator. I squared, what's that equivalent to? Yep, -1. So we have, it's 5 times I squared, so it's going to be 5 times -1. So our denominator is going to end up being -5. Our numerator is 3I. Nothing to simplify there. It's just 3I. And here's our final answer. There's no I in the denominator. Now, the reason why we have this is if you have the numerator, you have 3I, and you're dividing it by 5, it's a little easier to think in your head what's like 3 divided by -5. Well, it's 0.6. So 0.6 of an I is really what that is going to be, or 3/5 of an I. So that's the main basis why we have to get rid of i's in the denominator. It'd really be hard at the very beginning to say 3 divided by 5i. I have no clue how many i's that is at all because there's no I in the numerator to actually think about what we're dividing up. All right, so example 2. Let's look at the denominator. The denominator clearly is a monomial again, 3i. So we're going to just multiply by I. So here we have our numerator is a binomial. So I always put it in parentheses, especially when you have multiplication, because what that means is we need to multiply each of the terms by I. So I times 1 is I. I times a -4i is a -4i squared, or -4i squared. I use them interchangeably, a minus and negative. In our denominator, we have 3i times I. That is going to be 3i squared. So after you figure out what you have to multiply by and you multiply it out, now we look to simplify. Well, we have an I squared in the numerator. What is that going to equal? That equals -1. So this is where really got to think about our signs here. We have -4 times -1 is +4. So we have I from the very beginning plus 4. That's why I always take that sign, because if it's positive, then it just becomes plus. In the denominator, we have I squared. That's -1. 3 times -1 is -3. You should look at the end to see if you can simplify anything in the numerator and denominator if all the terms have something in common. They don't. And in the numerator, like the 3 or the number 1, it was 3 over -5. That didn't have anything you could simplify fraction-wise, so we are finished. All right, example 3. This is the first one. The first two were monomial denominators. Monomial denominators. And example 3, we have a binomial denominator, 3 plus 5i. When you have this, we need to multiply by something different. Multiplying by I just doesn't get rid of the I in the denominator. What you need to do is you multiply by the conjugate. So binomial denominators multiply by the conjugate. And you might be like, whoa, that's not spelled right. Sorry. Conjugate. Conjugate is you're just really just switching the sign of the imaginary. So it's 3 plus 5i. The conjugate will be 3 minus 5i. 3 minus 5i. So you're multiplying by 3 minus 5i over 3 minus 5i. And again, I didn't really speak about this, but why do you divide the top and bottom by it? Well, we're simplifying. We're not changing the value of this fraction. When you multiply by something like this, 3 minus 5i divided by 3 minus 5i, that's actually equivalent to 1. And when you multiply by something times 1, you're going to get the exact same value. That we're not changing the value of our original problem. You're multiplying by something that's equivalent to 1. So it's a weird looking 1, but it is a 1. So that's the premise why and that's up top, why I multiply by I divided by I. I should have talked about that earlier, but I didn't. But hopefully you can catch on now. So now we need to look at our numerators. We have a monomial I times a binomial. So let's multiply that in. 3 times I, 3i. 5i or a negative 5i times I is a negative 5i squared. In the denominator, this is where this gets fun. We have a binomial times a binomial. So I'm gonna change color so we have a little bit easier time seeing this. You do 3, so first multiply. So this is a FOIL, double distribution. You can do the Punnett square if you want. 3 times 3 is 9. 3 times negative 5 is a negative 5i is a negative 15i. And then we needed to distribute the positive 5i times 3 is a 15i. And positive 5i times a negative 5i is a negative 25i squared. I'm just going to make that fraction a little bigger. So after you multiply, it's always the next step is to simplify. So let's check out in the numerator what we can simplify. The only thing I can see is the I squared. What does the I squared equal? It equals negative 1. So I'm going to highlight it, negative 5 times negative 1. And that's going to equal positive 5, so plus 5. I just copied the 3i down from the first part of the problem. Next, in the denominator, so that's the numerator, 3 plus 5i. There's nothing to simplify. I guess you could write that. You probably should write it 5 plus 3i because it should be the real first and then imaginary, but I'm not worried about that right now. Let's look at our denominator. We have like terms, negative 15i plus 15i. So hopefully you're like, hey, that just simplify. Those simplify out. They're opposites of each other. They cancel. We have I squared, another one. It's negative 1. Take negative 25 times negative 1, and that's positive 25. So really, you bring that 9 down, we have 9 plus 25. And it always ends up being pretty nice like this. So that's 34. So the denominator no longer has an I in it. There's an I in the numerator, but that's okay. We just look at the 3. So now I'm looking, can we simplify the end? So I'm looking at just the coefficients or the terms, 3, 5, and 34. Can I simplify anything with those? Can I divide them all by the same number? Nope. So that is finished. All right, last example. So this is just like the last one. Look at your denominator. It's a binomial, the denominator. So then we can multiply by the conjugate, which is 4 plus 2i. 4 plus 2i. Let's multiply out our numerator. 7 times 4 is 28. Oh, let's put it in parentheses. It looks a little nicer. So 4 times 7 is 28. 7 times 2i is 14i. 3i times 4 is 12i. 3i times 2i is 6i squared. In the denominator, let's do that down there. So we have binomial times a binomial. 4 times 4 is 16. 4 times 2i is 8i. Negative 2i times 4 is a negative 8i. Look at those middle terms. Those are going to cancel. Sweet. Negative 2i times a positive 2i So negative 4i squared. All right. And another thing you should look at, or you should notice, is if you have a binomial times a binomial, you're going to have 4 terms, always, when you multiply it out, before you simplify. So always think of that. Just as a kind of a little backup, did you multiply everything you need to? And we did. All right, let's look at our like terms. We have like terms here, 14i plus 12i. You might be thinking, well, Mr. Johnson, can't simplify out? Just the denominators will. And we have I squared. I squared is negative 1. I'm going to work on that, so we'll have that at the end. So 6 times negative 1 is negative 6. So, all right, let's get this together. We have, so you have 28 minus 6 is 22. And then 14i plus 12i is 26i. So you should always have the real first, then imaginary, but I'm not. That's not something I am really going to be marking wrong. But just, you should have that. Denominator, we have like terms in the middle. They should be opposites of each other because the i's need to go away for us to have a simplified answer. Those do. Those cancel. 8i minus 8i. 0 i's, which is 0. We also have I squared here. I squared is negative 1. So you do negative 4 times negative 1 is a positive 4. So we have 16 plus 4 is 20. All right, so this is what I was talking about in the last problem. We look at our terms. We have 3 terms. We have 22, we have 26i, and 20. Look at all the numbers, the coefficients, and see if you can simplify. So can you divide them all by the same number? And sure can. We can all divide them all by 2. They're all even numbers, so I would start by dividing by 2. And then we see if, why did I put a negative there? Then I see if the 11, 13, and 10, can I divide all those by the same, another number? No. So that's our final answer, is 11 plus 13i over 10. All right, come to class with any questions. Thanks for listening.